So, hello everyone. This is another Monday with another easy happy hour session. Today we will be covering the topic series of CI/CD workflows with Easy. And for today's session, we have a colleague and from the scientific part, and he will be presenting a nice demo and presentation about the workflows with Easy. Before handing this session to our colleague, I would like to remind you that this session is being recorded. And at the end of the session, we will stop the recording in case you want to share any informal conversation about Easy. And also, before handing over the session, I would like to cover the highlights for today. So, tomorrow, Tuesday till Thursday, 23rd of April, there is the 11th Easy Build user meeting. I guess the registration has been closed even for online follow-up. In case someone requires further opening or info about the possibility to register, please feel free to reach out. As mentioned earlier, so next week on, there will be the Easy webinar series. There are 5 sessions. And you can find more about this on the link shown. And also at the final slide, which we will see today, there is also the QR code you can scan to get more information. Also, it's open registration and for free. There is the webinar 4 out of 5 for the Euro HPC Federation platform, authentication and authorization. That's on Wednesday, 29th of April. And finally, for today's highlights, there is the ISC 26 conference in Hamburg, 22nd till 26th of June. For now, I will hand the session to our colleague. So, Jean-Noël, session is yours.
Thanks for the introduction. So I am Jean-Noël, one of the developers of Espresso, and I would like to share with you how we are using CI/CD workflows using the Easy GitHub action. Let's say you have developed a piece of software for your research, and you have shared it with the community of researchers. You have put it on GitHub under an open source and reusable license, and slowly you are building a loving community of users and possibly developers. They are helping the software by providing you with bug reports or providing patches. And at some point, they would like to be more active in the contributions. Maybe they would like to develop new feature for your software, or maybe they would like to integrate your software with other software. And what you will find is very quickly that different people have different software stacks and sometimes different hardware. And this can lead to sources of friction. For example, you can have a test that is passing on your x86 hardware, but someone using an ARM machine will have a failing test because the 10th decimal place of a result is wrong. This does not invalidate the software, but this causes like annoyances, because now you have to adjust the tolerances of your test for every single hardware. And if someone is installing a newer version of a dependency, which has changed the API, now your software is no longer able to call this newer software. And again, you have frictions and bug reports because users would like to be able to use the most recent versions of their software stack. And in situation, you would like to have a software environment where you can easily control both the software stacks, all the versions of all dependencies, and also the hardware. And this is what we are going to present today. So one practice we would like to adopt very early on is called continuous integration. That's a technique used in software engineering where you try to develop new features or bug fixes on short release cycles, typically a few days to at most a week. The idea being that multiple people will work in parallel on different aspects of your software and will frequently integrate or merge the changes into the main branch. And to simplify this practice, we like to use automated build and test workflows that will make sure that before you merge a contribution, you can confirm that the feature is not breaking any existing feature, and also that it is well tested. In the image below, you see a pull request that has been merged into the Pimbe main branch, where the Pimbe software was tested against Espresso 4.2 and Espresso 5.0. And it was also monitored for code coverage. So it's not enough to say your software passed the test suite. You also have to make sure that every single feature in the code was tested. And this is what code coverage is doing. Once you have that, you can now think about making your software read for release at any time. The idea being you have a way to prove that your software is correct and well covered by tests. And now you can go one step further with continuous delivery and say, every time we merge to the main branch, the state of the main branch is good enough to be released. It will not be automatically released, but if you decide to do so, you only have to press one button and it will be deployed to a software forge like PyPy, EasyBuild, EESSI, or so on. Some cases you will see continuous deployment, which is one step further. Every time you merge a contribution, it is automatically deployed. There is no human intervention anymore. You will see this, for example, in Docker images. So Fedora, OpenSUSE, Ubuntu, they create a rolling release of their Docker image. And so you as a user, you can write a Docker file that says from Ubuntu :24, and then you write your installation scripts, and this will pick up the most recent version of the Ubuntu 24 stack. And I think Ubuntu deploys a new stack of the Docker image every 2 days or every day, mostly. In the context of with the software, you can see continuous deployment in artifacts. For example, Espresso and Pimbe, they will deploy the user guide once a day. So in the morning, there's a workflow that starts automatically that checks if in the day prior there was any new merge in the main branch. And if so, it will download the user guide that was built inside of the test workflow and automatically upload it to the website. So our users can always access the user guide of the most recent commit in the main branch of Espresso and Pimbe. Now, to make things easier, we have developed the EESSI GitHub action. Typically, in a GitHub runner, you can install from the Ubuntu packages, or you can install from PyPy or from other software repositories. But sometimes you have some scientific software which is only available as source files, like Espresso, and here you have to build it yourself. And this causes delays in the feedback you get from automated workflows, because in the case of Pimbe, you had to wait 15 minutes for Espresso to be built before you can start testing the Pimbe software. So this is a delay that annoys the developers who would like to get feedback very quickly. It is also burning the credit because we have a fixed amount of free usage every month, and the test suite itself takes 5 minutes, but the build part takes 15 minutes. There are, of course, ways to cache artifacts and reuse them, but we found out that the EESSI GitHub action provides you with a much more convenient interface, because you build software once in a server for every single architecture, and now you can download it from any GitHub runner, from any HPC cluster, or from any workstation where EESSI is installed. For GitHub hosted runners, you have access to x86 and ARM64 CPUs. And these will typically be useful for most applications that rely on testing. The workflows are available in a tutorial on easy.io. And in the following slides, I will go through this workflow in small chunks. Like, the tutorial itself looks pretty long, but if you break it down into smaller elements, you will see it is not that complicated. The workflow themselves, they rely on YAML files, which are text files where you describe the actions you'd like to take to build and test your software. And it is pretty easy to read. It is designed to be both machine readable and human readable. You will see that these YAML files are made of text fields. The first one here is called name. You would like to give a name for your workflow. A workflow is divided into multiple jobs or tasks, and you can have more than one workflow triggered for every pull request or commit. This is what the on section is about. So there you can define how you would like this workflow to be triggered. It can be for every pull request or for every push to a branch, including pull request branches. There are extra options. You can also say triggered when the user clicks on a button. What's called a dispatch workflow. And you can also trigger on a webhook or any other action. It can also be an action triggered from another workflow. So you can have two Git repositories communicate via workflows. But here we'll keep it simple and we'll only trigger on Git pushes. Next, we have the jobs list. This is where you will define your different jobs. In our case, for this slide, we only have one job called test suite. You can have more than one job. You can also define a job matrix. For example, you could define two vectors. One will contain Ubuntu x86, Ubuntu ARM64, and a second vector with Espresso 4.2, Espresso 5.0. And you can now ask GitHub to compute the Cartesian product of these two vectors. And now you have a matrix with 4 elements, and 4 jobs will run in parallel in 4 different GitHub runners. The test suite, in this case, will run on the Ubuntu latest, which is by default x86. And then we define the steps. Each step will define a self-contained action. The first one is typically the checkout action, which will call git clone on your repository. Then we will use the EESSI GitHub action, and we'll define the stack version 2023-06. There is one stack version every 2 years on average, and each stack version contains multiple comparator chains. Typically, they contain 3 GCC toolchains and at least 1 LLVM toolchain. Then we have a step to install dependencies. Just a quick note on the color code. So green is for a string, and blue is for multi-line scripts, like bash scripts. In this case, I'm using the pipe symbol to introduce a multi-line script. If there was no pipe symbol, it would be a single line script. The first line in this script is module use and a very long string that I had to break down into multiple lines. This is entirely optional. By default, when you module load software, it will only look into the stable or let's say official releases of software on the software.easy.io stack. But in this case, I would like to be able to look into the dev.easy.io stack, which contains pre-releases of software. Sometimes we have users who would like to use Espresso with a new feature, but the next official release of Espresso will be in 6 months. So what we will do in this case is create a pre-release software that contains the feature, and then they can use that in their own GitHub workflows. When you module load Espresso, if you want to module load from the official releases, it will be the syntax espresso /4.2.2-first-2023b. If you module load from the dev EESSI.io, you have to use the commit ID as the unique identifier. And here I had to use 3 dots to shrink the commit ID because it is too long to fit in the slide. Then we have the module the module save Espresso, which will save the current stack of loaded software into a file, not just Espresso, but also all dependencies like HDF5 or the OpenGlide visualizer, NumPy, SciPy, and so on. So everything is saved into a file so that in a future step, I can recall this list of software and not have to type again module load, and module use. And then we have a Python environment created where we will ask the environment to give priority to the system-wide available packages, which includes EESSI. This way, when we pip install software, it will first look at Python packages available in EESSI, such as NumPy and SciPy, and if it finds them, it will not install them. It will only install things not available already in EESSI. And you might be wondering, why don't we put everything into EESSI? Well, in this case, we have a few packages that are not super relevant for software development. These are packages that are specific to run CI workflows. Think like style formatters for Python code, code coverage softwares, or Sphinx to build documentation with Sphinx plugins. All of these are always updated regularly by the maintenance team because we would like to, let's say, modify the way the user guide looks. We would like to add a new JavaScript, or we would like to update the formatter style, and it doesn't make sense to impose these cosmetic-like changes to EESSI. So we prefer to keep them into the CI workflow. The test suite itself is pretty straightforward. We restore the Espresso modules, again, with all the dependencies. We reactivate the Python environment. We set a few environment variables. Those are specific to OpenMP. On your workstation, you would have different variables, but because OpenMP in the GitHub runners behave differently, we need to set them to different values. In particular, because we have a virtual environment in this GitHub runner, we can't really control where the CPUs are on the hardware because everything is virtualized. So we set environments that make sense for OpenMP to run in this virtual machine. Then we have a make test command where we run a test with 4 jobs in parallel because we have 4 CPUs in an x86 GitHub runner. I think for ARM runners, you only have 3 CPUs, so you would have to use -J3. And we enable coverage. This way, when we run a test suite, we automatically write to different files which lines of code were covered by the execution. And then we run the coverage program to assemble all these small files into one big report in the XML format, which we can, in the next step, upload to the coverage website. So we can see in the GitHub user interface, okay, this pull request has, let's say, 99% coverage. And this way we know that the person who proposed the code change did in fact write test for every single new feature he or she introduced in the change list. This is pretty much it for the workflow. I have a few more slides explaining how to remotely log in into a running workflow. So you would typically not use that in production, but only for testing. It can be useful in the beginning when you are new to workflows and you would like to find your way into how these virtual machines are set up, in which folders everything is being installed, what is the state of the environment variables, because sometimes you might find it difficult to get code coverage tools to properly pick up the files in your environment. So if you have a need to remotely log in into a running action, you can do so. In this particular example, I'm using Teammate, which allows me to use SSH to log into a running action and inherit all of the environment variables of the action. And if you prefer tmux and upterm, this is an alternative. In this case, you would log in, but from a different session. So you would not inherit any of the environment variable, and thus you need to have this extra step where you export the current environment variables into a file, into a bash profile, which will be automatically opened when you log into the machine with SSH. Now we can have a quick demo. I have here the pin-based software. I have cloned it from the main branch, and I have added the upterm example. So I'm removing the 4.2 Espresso release and only keeping the 5.0 release. I'm removing the test suite because it is 5 minutes long, and I'm adding the commands I just showed to trigger the action and open the terminal. So if I push this to my fork and go to my actions in Pimbe, I should see a new action starting up. There is only one job in the matrix. And we can see here that we are triggering the checkout. So we are git cloning the Pimbe repository. We are validating the station file. Here we are triggering the EESSI GitHub action. So it has to download from or install from Ubuntu a few packages so that it can fuse mount this CVMFS shared folder. So CVMFS is a shared folder in the sense that if you ls into it or if you cd into it, it will establish a connection to discern servers, and it will download pre-built binaries of Espresso, GROMACS, LAMPS, TensorFlow, NumPy, whatever is available in EESSI. And there's a caching mechanism so that the first time you download the package on the fly, it will take maybe a few milliseconds, but then next time it will be already available locally on your workstation. So this step takes like 40 seconds. Then we can access the CVMFS. And then we'll be able to install Espresso and create the Python virtual environment. As this run, I have to prepare another terminal. So in this one, I have logged in I have enabled my SSH agent, so I am now able to log into any server that uses my SSH key. And here we are initializing the L-mode, which is the backend to control the module load function. We have set up the 2023-06 software stack. And it should now slowly install a few packages from PyPy. Any second. Okay, it's taking a bit longer than usual. I can take this opportunity to also mention that by default, when you use the EESSI GitHub action, it will detect which microarchitecture is available on the host machine. And if you want to use the dev ECIO, you don't have as much diversity yet. So we only support Zen 2, Zen 4, and 2 versions of ARM. I think Neoverse V1 and N1. So when you need to use the dev EESSI IO to get pre-releases, you have to provide a backward compatible version, in this case Zen 2, because the runner itself is Zen 3, it's an AMD EPYC. And at some point, I guess these pre-releases will become available on more architectures. But for now, you can always use a backward compatible version. And for ARM runners on GitHub, I think you should use the NVIDIA/Grace architecture. Okay, here we can see the PyPy. And most of those are actually things that are only used for the test suite, like CMake, which is used to run the C test. And now we can finally log in with this command. And now I am inside the runner. I can ls git log. I can also show different folders. I can have a look at the tree structure. I can ask where am I. I can also echo environment variables and see what's inside. So this is helpful when you write your first workflow and something is not going the way you intended to go, and you would like to understand what the issue is. It is more convenient to remotely log in and test it yourself than to push a commit, wait 2 minutes, get a feedback, and then push another commit and do that in a loop. Here you can directly interact with the cloud instance, and you can also trigger the test suite, so you can actually try to reproduce a bug or any issue related to hardware precision. And another nice thing about this is it doesn't matter who else is working on your software. You all have a shared cloud service with a software stack you control, because you are defining which EC version you're using and which toolchain in this version you are using. You also control which hardware the GitHub runner is running on. And so if you have any disagreement about what should be the correct value at the 10th decimal place in an ARM, you can use the GitHub action to agree on the same environment and say, okay, this tolerance is relevant for the application. And if there is a bug report that you cannot reproduce locally in your workstation because you are missing a specific version of a dependency, you can ask the person who reported the bug to adapt the bug report to reproduce the issue on a GitHub runner, so you can then remotely log in and interact with the bug live from anywhere, from your workstation, from your laptop, from your tablet, anything you like. This pretty much concludes this discussion, and I am now open for questions.
Thank you, Jean-Noel. Maybe we can go back to the slides. So just a reminder that next Monday, there will be no happy hour session. Instead, there will be the Easy Webinar Series 2026. And you can scan the QR code to get more information and even to follow the page where you can register for the webinar series. I guess with this, Jean-Noel concluded what he had to present, and we are open for questions. We already have a question from Ben. Can you pick that up, Jean-Noel? So maybe I can ask this, what does the GitHub action do exactly?
The GitHub action will set up the easy environment, so you can module load software that has been built for EESSI. So typically, if you look at Espresso, it is only available right now on Fedora, but it only provides you with the latest release of Espresso. And if you want to have the most recent version of Espresso, a pre-release version, you would have to build it yourself. And this is something that will take time on your runner, not just for the build itself, but also for the testing, because the way these runners work, they don't have a fixed limit for the RAM. But when you use a lot of RAM, it will automatically decrease the priority of your task on the CPU, so that concurrent jobs from other GitHub pods will have access to more resources from your runner. So if you want to build Espresso, you have to first install 300 megabytes of dependencies, mostly the compiler and a few big libraries, which means that when you run your test suite, you already consume half a gigabyte of RAM, and thus you get penalized in the runtime. All of your tests run a little bit slower, a few percent slower, because the RAM is being consumed, and this is factored in the frequency of your CPU. If your dependencies only exist, or if they are already available on Ubuntu on Ubuntu repositories, or instead of Conda environments or PyPy, then sure, then you don't really need EESSI. But if you have a need for a software which is not available in these platforms, EESSI can be like an alternative. And also with EESSI, you get the exact same versions as your users would have on, let's say, HPC clusters. Because one of the main appeal of EESSI is to run on HPC clusters, and now you can have access to exact same versions of all dependencies as you would have on a cluster. You no longer have to think about multiple versions. You know that your users will be using, let's say, 2023B stack. And so you can use the same stack in your cloud runner for GitHub or on your workstation. Any bug report will be easy to treat, because there is only one version of all dependencies.
So just to add one more thing, John Noel, so it's not just the version, it's even that the software that is there is built the same way. So the users running the same software from Easy will have the exact same uh, behavior, so that, and as you mentioned, it will be easy to reproduce the bug or if we're trying to troubleshoot something. Does this answer your question, Ben? We also have some clarifications on the chat from Thomas that, as also Jean-Noel mentioned, so it also uses the GitHub Actions is used to install certain VMFS with the client so that you get access to Easy, which exposes almost like 700 software packages. Any other questions related to CI/CD workflows with Easy? If not, maybe I can stop the recording for more informal conversation. So before I stop, just remember to scan the QR code or follow the link to register for the webinar series starting next week. And also, as mentioned earlier, so we will be continuing the Easy Happy Hours after the webinar series. In case you want to present something related to Easy, feel free to reach out. I will stop the recording for now.